Good morning. Welcome back to NIDays Singapore 2016. I am so excited to kick off the second part of today's event. And I'm also very sure that you will be excited as well because we have planned for an incredible event. And I'm confident that this will be the best NIDays ever. So Mate mentioned earlier in the morning that the common trend in all of these disruptive companies is to leverage on an open technology platform and a large ecosystems of users and developers. The platform enables these companies to lower the engineering barrier and to move into new application areas. The ecosystems allow them to compete more efficiently and also in a more innovative way in the marketplace. And this is not new, actually. In fact, engineers and scientists have been harnessing the power of the NI platform and the vibrant ecosystems of partners and third-party IPs to help them to overcome the challenge of converging technologies in tests, measurements, and control solutions. And today, I am very, very happy to be able to invite 4 of these successful customers and partners onto the stage to talk about their applications, the challenges that they face, and most importantly, how they are able to leverage on the platform and the ecosystems to help them address the engineering problems that they have. And with that, I would like to invite my first speaker onto the stage, Prof. Chen from Singapore Institute of Technology.
Hi, good morning.
Good morning, Prof.
Good morning,
Very
everyone.
nice to have you. Right. So, Prof, I know that Singapore Institute of Technology, or SIT for short, was set up in 2009. Yeah. And it's also popularly known as the University of Applied Learning. Yes. Will you be able to share to the audience here about the universities and the programs that SIT is offering?
Sure. Let me briefly introduce SIT. So SIT is the Singapore Institute of Technology. It's the 5th university and the newest university of Singapore. So many people ask, why SIT? Why do we need SIT? So let's look at Singapore education system first. So after O-levels, 28% of the cohort go to A-level, 46% go to polytechnics, and 23% go to ITE. So after this, most of A-level students go to university because this is a natural pathway for them. And many polytechnic students actually choose to work because they are work ready. So as a result, only 30% of the cohort actually join university. And the target actually for the cohort participation rate will be 40% in year 2020. So that means if we want to increase from 30% to 40%, we need more polytechnic students to join university. And SIT actually providing a new applied learning pathway for these students. So next, let me go through the brief history of SIT. So in year 2009, SIT was established, and we only offer overseas university program at that time. So in 2012, the Committee on University Education Pathway beyond 2015 recommended SIT should become an autonomous university. And in year 2014, SIT has officially become the 5th university of Singapore. And in the same year, actually, we offer 3 new SIT-owned degree programs. And in year 2015, SIT offer 5 more programs, and we have enrolled 4,000 students. So in terms of the student intake numbers, SIT actually is number 3 in Singapore, just after NUS and NTU. So in year 2016, SIT offered 7 more programs, which includes the telematics program, which I'm going to discuss in more detail later.
Now, thank you very much for sharing, Prof. So if I remember my math, so this must have been a very exciting 7 years of journey for SIT. And from the slides that you show, it really sees that the number of students enrollment has increased. The number of programs has also increased. But what I also wanted you to take this opportunity to share with the audience is that how SIT pioneered the applied learning pathologies in your institution.
Yes, SIT is pioneering applied learning pathway. So this includes a few very key components. The first one is Enterprise and Innovation Hub is set up in SIT, and we are working very closely with industries and communities to develop innovative products and solutions for the companies. The second one is the project-based pedagogy. Basically, we believe the student can learn better by doing. This is actually in line with the NI's Do Engineering program. And for all SIT programs, we have this program called Integrated Work Study Program. Basically, the student will work in the companies for 8 to 12 months. Okay, so if you compare to industry attachment from other AUs, our program is much longer in duration, and also it's much more structured to give students the real working experience. And also, we are building up the symbiotic relationship with the industry and community. Next, I want to go through the new degree program in telematics for intelligent transportation systems engineering. So this program we just launched this year. So now we have the first batch of 50 students in the campus now. So the first question you may ask is, what is telematics? So telematics actually is the work is coming from telecommunication plus the informatics. So you will see this program actually is a combination of electrical engineering and IT. And for the electrical engineering part, we talk about the sensors, embedded system design, wireless communication. For the ICT part, basically we'll talk about the information processing and the data analytics, etc. So why do we need this program? Basically, I want to mention quite a number of very important developments in this area. Actually, some of the previous speakers have already mentioned this one. So the first one is the Smart Mobility 2030, which is proposed by LTA and also the ITS Singapore. Basically, this Smart Mobility 2030 shows you how our future transport system look like in year 2030. So from the picture here, you will see a satellite-based system, which is our next generation ERP system. You will see autonomous driving vehicles, also you will see green vehicles, and also vehicular communication. So for the driverless car is considered as one of the disruptive technologies. And I think this is going to be a very exciting topic for the next few years. And also for the vehicular communications, people also talk about the V2X technology, V2V technologies. And through the stronger connectivities between vehicles, a lot of information can be shared, can be used to enhance the safety and also to ease the congestion, right? And the connected vehicles is part of the bigger umbrella of Internet of Things. NI actually is very active in this IoT domain as well. And for this telematics program, for SIT program, basically, we use a trimester-based system. Basically, every year we have 3 trimesters. Each trimester is 4 months. So for telematics program, the first 2 years are the foundation modules in electrical engineering and IT. So the student will start the IWSC program from the last trimester of 2nd year. So it lasts for 8 months. So when the student come back from IWSC, they will continue with the more specialized module in transportation or automotive engineering. So after 3 years, they will graduate with a Bachelor of Engineering. And for those students doing well in the bachelor program, they will proceed to the final year to get a Master of Engineering Technology.
Thank you very much, Prof, for sharing. I must say that the telematics program is very well aligned to the current technology trend that the world is in today. In fact, I also say that SIT is probably a couple of steps ahead in getting their students trained and plugged into the technology frontier. Also, I would like to take this opportunity to share that SIT and NI will be signing a memorandum of understanding later in the afternoon today. With this MOU signing, SIT will be the first university in Singapore to have a LabVIEW Academy. So, Prof, will you be able to share a little bit about this collaboration that is going to take place?
Yeah, we want to work with NI. Basically, NI provides an integrated solution of hardware and software, which is very useful to develop many modules for telematics program, such as the signal and systems, embedded system design, wireless communication. And also, NI has many industry partners, which is called NI partners. Actually, our students can work with NI partners for the IWSP and also for various projects. And the student can develop innovative products and solutions for these companies. And also, our students will get the training to get the LabVIEW certification, which is the internationally recognized certificate. And also, they will get the relevant industry experience. And we are going to sign an MOU with NI later today. So this MOU actually covers quite a number of very important topics. The first one is the certification and software. Basically, NI will provide the training for the LabVIEW Core 1 and Core 2, and all students will go for the CLAD and CLD examination. And SIT will be the first university to set up the LabVIEW Academy in Singapore, and also will be the first university to have the students to go for the CLD exam. And the NI actually will also organize the technical sharing sessions for our faculty and students. And also NI will sponsor the industry awards for those students are doing well in their projects using LabVIEW. And also NI will support SIT programs such as the dual study and also the IWSP and also capstone projects through the NI partners.
Thank you very much for sharing, Prof. We at NI are really very excited about these collaborations because we feel that through these collaborations, we are able to help the students of SIT to gain competency in LabVIEW programming. And this will really help them to use it as a productive tool when they go about doing their projects or research work. In addition, the collaborations also allow the students to gain the relevant industry experience. And on top of that, also to acquire a certification called the CLAD or the CLD, which is internationally recognized, which we believe that when the students graduate, they will be more prepared, well-positioned to enter into the workforce. So once again, thank you, Prof.
Thank you, Vaij.
Thank you very much.
Thank you, everybody.
Now, the second speaker that I'd like to invite onto the stage is an alliance partner of National Instruments. The company was set up in 2013. So this makes that company a relatively new company of about 3 years old. But it is a company that is rapidly acquiring a reputation as the expert in machine vision and imaging technology. So with that, I would like to welcome Winston Hu of Acusys and JR, Partner Manager of National Instruments, up on stage. Good morning, Winston.
Morning.
Very nice to have you.
Morning, Vaij.
Good morning, JR. Well met again. Right, so to kick things, I guess the audience will be wondering, why do I invite a colleague from NI to come on stage where we are here to talk about platform and ecosystems? So JR, perhaps you can share a little bit about your role in NI and how do we support the partner program which form part of the ecosystem?
Thank you, Vaij. As you have pointed out in your opening slide, NI is all about platform and ecosystem. So I work with partners in the ASEAN, Australia, and New Zealand region to help to groom and grow these partners in this ecosystem. Many of our partners, as you've seen from out, they also have a lot of booths set up. They have actually benefited substantially by actually leveraging on these partner ecosystems to build and grow their business. So Winston, with that, could you give everybody a quick introduction about your company, Acusys?
Yeah, sure. So Acusys, as mentioned, we are a fairly young company. We are in our 4th year right now. So we are also one of the younger members of NI Alliance Partner Program. We are slightly different than the other partner, as in we only focus on vision or vision-related projects only. So in other words, we don't know much about anything except vision. So the service that we provide to our customer is like vision system integration, system design, software development, algorithm development, consultation, training, and component trading. Yes.
Thank you, Vincent. Can I, within 3 years, you have managed to build such deep capabilities in machine vision. This is truly impressive. Would you be able to share with everybody an application that you developed recently, and what were some of the challenges that you experienced?
Yeah. So we have one of the projects that we have done recently that I would like to share. So we have one of these customers who do electrical grooming products. For example, it's like electrical shaver, electrical trimmer. So before the assembly process starts, parts needs to be lubricated by dispensing lubricant on it. So there's challenges faced by the customer, namely all the process is being done still by human workforce. And of course, it introduced a lot of human error into the process. So other than that, the manpower also limit the production throughput of our customer. So our task in this project is actually to automate the dispensing process by implementing robotics vision. There is some challenge that we face also. For example, the deployment error is actually very high with human traffic, and there is unfavorable ambient light disturbance, and we have a very small deployment area. So we also have been given a very short development time, and we also have encountered some communication issue with the robots. Yeah.
These are truly challenging times. So Vincent, what is the solution that you actually developed, and how did you manage to overcome some of these challenges?
Yes. So our solution is to choose Vision Builder from the NI Vision platform together with LabVIEW. The software that we have wrote is run within CVS controller from NI. And this controller basically responsible for image capturing, image analysis, image processing, and I/O synchronization, and TCP communication with the robots. So when the result is ready from the CVS controller, it will send a string of TCP phrase to the robot, and the robot will perform the dispensing action.
Thank you very much, Winston, for sharing with us the configuration to the application that you were describing earlier. Now, I must also say that this slide is one slide that I like pretty much. It has the NI Compact Vision System, it has the NI LabVIEW software, and it also has the NI Vision Builder for automated inspections, which is a script-based configurable software that NI provides to engineers and scientists who want to rapidly prototype machine vision application. Now, having showed this, do you think you have a video to show to the audience here about how the physical system deployments looks like?
Sure. So in fact, I have two videos over here. Over here, you can already see image has already been captured, send the result to the robot, and then the robot is performing different dispensing action onto the unit. And one can actually notice the same program is actually applicable to different parts, different model, and different unit count on the tray. So this is on two different occasions, but with the same system. When we place in the unit, the target onto the tray, then we will capture and then analyze all the position of the unit. This is a screen of the VVAI deployment. Yeah.
I see. Thank you very much, Vincent. I mean, you are really great. I asked for one video, you show me two videos. And with all complex systems like what we have seen in this video itself, I am very sure that there are challenges that you face while developing it. Will you be able to share some of these challenges that you face specifically when working on this application?
Yeah. So as you can see from the video, right, the vision processing part is performing pretty well. So we are able to cater for all the different parts. But we do encounter one challenge whereby we need to send a very, very long TCP phrase to the robot side. So these phrases differ in length from model to model. It's about 1,000+ characters, and it needs to be in a very specific format to be able to recognize by the robot. So the phrase itself consists, for example, like header, and then model information, unit count, followed by maybe 50 or 80 parts of the pass field information, XY location, angular rotation of the part, and end with a footer. So to do this in Vision Builder, it is actually a very tedious project. And in fact, to do this in any smart vision software, it is a very tedious process. Our workaround on this is actually to implement a custom VI function from LabVIEW that we have built and job done. So in fact, this step actually takes us like around 20 minutes just to develop this custom function. So by using NI platform, we have actually achieved a very great time saving in terms of the development time from months to weeks. And in fact, the vision part that you saw in the project just now is done within a week of time. The next 3 points is one thing that I very like about NI. So as from my point of view, NI is one of the few companies that provide customer with a development environment, namely the LabVIEW, a Vision SDK named as VDM and Vision Builder in NI ecosystem, and also Vision processor hardware. So as a Vision system developer, this is kind of felt like a complete combo meal ready for us. So next, I also have one of our feedback from our customer that I'd like to share, that he mentioned that the automation system helped us to improve our yield and reduce human error. In future, we are looking to expand such system to other process.
Vincent, at this point in time, I'm very tempted to ask you a very next question. Can you share with everybody how has NI platform enabled you to attain a competitive edge in the industry?
Yeah, so there's a lot of different third-party products or competitor products outside. It depends on the nature of the project, where we might choose VDM for that project, the Vision SDK, or Vision Builder for that project, which is actually a smart vision software. So in terms of Vision SDK, to compare with other platforms, right, the time saving by using VDM is LabVIEW is much, much, much shorter than in comparison by using some other SDK in C or C# environment. And bear in mind that there's a high learning curve on the other SDK in that environment also. So in comparison, if we were to choose a smart vision software in a project, then we are looking for, NI have this advantage of providing a complete and ready I/O hardware and industrial communication protocol ready for us. And sometimes the third party, the other platform smart vision software do not have this functionality to accept third party DLLs. So if let's say we will look into the hardware processor, I felt that NI have this high flexibility, as in some other platform, we have lack of selection of camera, for example, is very restricted. And for example, in some cases, we have actually so-called constraint in accommodating third-party library. And in some instance, certain software, like smart vision software, can be catered for certain products, and SDK can be catered for certain controller only. And in a sense, NI hardware is built and designed to run both at the same time. So in future, we are looking to incorporate FPGA visions into our system. We have heard a lot of great things about that, and we know that NI have this technology that we would like to input in. And also, we are looking to put in other process automation into our vision software.
Thank you very much, Winston, for sharing with us your applications and also sharing with us your next steps. In fact, talking about next step, I thought I also like to share with you about this technology that National Instruments have, which is called FPGA, which I think is no surprise to most of you here. The FPGA technologies is available in the Compact Rail platform that we have. It is available in the FlexRail module that we have that is plugged into the PXI. It is also available in our software-defined instruments platform. And of course, in your case, Winston, the FPGA is also available in the Compact Vision system that we have. And with this FPGA, it includes these co-computing capabilities that really allow you to program in your real-time algorithms into the platform and allow you to go after more complex, sexy applications out there. And having said that, I thought I want to pose the questions to Jaya that as we expose to our partners the sophisticated advanced technologies to help them to conquer new applications, what kind of support system NI have through the partner programs to enable our partners to quickly learn all these features or the capability?
Thanks, YH. That's a very, very great question. So NI has got a very comprehensive training programs for partners. So partners who are on board, they can use these training programs to actually build deep down capabilities in the NI platform, which actually allows them to build small to very, very complex systems. So typically, some of the trainings that recently we did for partners are in the area of embedded, where partners were able to acquire practical programming skills to program an application in the FPGA. And some other forms of trainings that we have are also in the area of how to program and configure a condition monitoring systems. So these are some of the programs that we have, not covering the many others that we include. So these are things effectively there for partners, and many of the partners has actually, in fact, benefited a lot from these training programs.
Thank you very much. Thank you, Vincent.
Thank you.
Thank you, Jaya.
Thank you, YH.
Thank you, everyone.
Thank you.
Now, the third speaker that I would like to invite on stage is from ARTC. Advanced Remanufacturing Technology Center, or ARTC for short, is a platform built upon strong partnerships across the supply chain, complemented by technical support from the research institute as well as the academia. Purposely built facilities and underpinned by a world-class research expertise, it hopes to help and rapidly develop solutions that can enable this technology to be deployed into industrial production. So with that, I would like to invite Dr. Chen from ARTC to share about one of his latest applications that ARTC is working on.
Hi, Orange.
Good afternoon, Dr. Chen.
Hi, my name is Chen Fang from ARTC.
Right. Very nice to have you here, Dr. Chen. Now, before we jump straight into what are the challenges that industry are facing and how ARTC are coming in to work on it, can you also share with us a little bit about the mission statement of ARTC and also a little bit about ARTC in general?
Sure, my pleasure. As you can see, ARTC is the business model, both private and public. We are under A-Star in collaboration with NTU, and we are also working closely with our industry members like IHI, Rolls-Royce, and currently we have 42 members which cover both the technique end user and the provider. As you can see, currently we have 5 main teams: repair, restoration, surface enhancement, robotics, additive manufacturing, and product verification. I should say currently we are working closely with NI mostly under product verification. We are developing solutions of inspection, machine vision, NDT, and other measurement projects.
Wow, that is really, really exciting. It really shows that ARTCs are in the thick of a lot of this cutting-edge technology and addressing some of the real concerns that the manufacturing out there are facing. And as I mentioned earlier, will you be able to share a little bit about one of the challenges that you are working on currently?
Okay, because we are serving so many industry members, so here today I share with you some of the common interests from our industry members. For example, we know that for a machine vision, normally we have such common challenges if the illumination is low, or if the object is moving, maybe even, it's even worse. So to settle these problems, we are developing our test beds 1 to synchronize the lighting, the camera, and other sensor into one system. And sometimes we feel that it's quite important to replace the human sentencing into our algorithm. That means we do some artificial intelligence work. We know that our human beings sometimes make very reliable decisions, but sometimes subjective. So we need to transfer the knowledge from the experienced technicians to our system. We know that our human beings are quite clever. We know that, okay, this image is a very poor quality image, but we know where is black, where is white. But we need to do the pre-processing for the system to do machine vision image processing. And it's always time-consuming and needs quite a lot higher requirements on computing power. So based on these considerations, we develop our second test beds to address the dynamic inspection with intelligent decision-making.
Thank you very much for sharing about some of the challenges that the manufacturing industry are facing. Now, can you jump straight and give us a deep dive on these 2 test beds that you just shared with us?
Okay, so our test beds 1, we are focusing on synchronization. So as you can see in the casing or in the gearbox, sometimes the illumination is quite low and sometimes the object is moving very fast. So we need a ambient light for observation purpose or for video taking. And for a high quality image, we need some special lighting to make a uniform and very short path lighting. And we also need position sensors to make sure during the very short time we capture the image, the object is rightly in the center of our field of view. And of course, most important, we need an image capturing system. So we have the requirements of high speed, high throughput, and as a developer, we always prefer a single programming platform. So in this development work, we use LabVIEW and a portable DAQ system to synchronize everything. So as you can see, the system reads the signal from the position sensor, knows that, okay, this object is within our shooting range. Then we off the ambient light to terminate the observation mode. Then we take image using the camera with assistance of some special lighting. Okay, this is how the system works. If we use ambient light to take image, the image will be very dark and blur. If we use some flash directly attached to the camera, the lighting, the illumination is not uniform. So they are not suitable for machine vision, for image processing. So we need some specially reconfigured lighting system to give us a high quality image. This is how the system works. As you can see, we terminate the observation mode, then run the image processing mode. And another software panel will show you how we take the image. Okay, this is the video. Every time the image taken is within the center of the object is within the central area of the image. That means our position sensor works. And as you can see, in real time, the defect can be detected. So all the sensors, multiple lightings, and cameras are synchronized in this system.
Very nice, Dr. Chen. Now, you are going to go about test bed 2, and I'm sorry I interrupt you because I realized that one of the difference between test bed 1 and test bed 2 is that there's intelligence in test bed 2.
Yeah, so for test bed 2, we are pursuing not only to be fast, but also to be smart. Okay, as you can see, this is a common story of human sentencing. This technician can be very experienced. Using his eye, he knows which samples to be accepted or rejected. For example, if the surface is perfect, we accept that. If the surface is full of these corrosion dots, we reject it. And sometimes the cases are in between. We should make decision whether it's worth repairing or not. So we need to transfer the knowledge from the human being, the brain, to our algorithm. Okay, we extract the 2 key parameters, which are the defect density and defect size. So as you can see, the red points means we can accept that, and the red cross means those cases we should reject. And this is the decision made by the technician. And as you can see, the triangular area is what we draw using our algorithm. Means that, okay, this area is the acceptance role. And be careful, on the bordering area, we have some outliers there. That means our human sentencing is not always consistent. Right. Okay, to be clearer, these criteria can be translated into different failure modes, which shows a clearer physical meaning. Okay, as you can see, we can separate that into a 4-cell matrix. Firstly, we have, if the defect density is low, defect size is small, we accept that. If it's too big, no matter how low the density is, we reject that. If the defects are too dense, no matter how small they are, we reject that. And if both dense and big, we reject them. And we have a special area in this triangular area. That means, okay, we reject it because we feel uncomfortable. Why uncomfortable? It's fairly big and fairly dense. Okay, so these are 2 setups of the system. So as you can see, we use the FPGA technique to do the pre-processing of the image, because we know the image processing is always very heavy computation work.
Right.
So we can use the industry camera, but of course we can also use smart camera. And using the FPGA, we do image pre-processing. We reduce the noise level, then we do some normalization of the image, and the host system can do decision making, can do the real-time display. But of course, here we use smart camera. Sometimes we can even make the decision within the onboard camera. So this is how the system works. Dynamically, we move the sample or move the inspection system. Then how we show the results in real time. As you can see, we have already defined 4 typical failure modes here. We use FPGA, we use LabVIEW to package the program into an installer. Okay, as you can see, the 2 traffic lights show you whether it's too big or too dense, or fairly big, fairly dense, to cover the 4 typical failure modes and make the decision whether accept or not.
Right.
Yeah. So, as a summary, we are pursuing high speed and high throughput in many industrial areas. Traditionally, 10 years back, we need to learn so much knowledge. And as 10 years ago, as a mechanical engineering students, very proud I feel, all of them. So today we can use a single platform. So we make sure our scientists, our engineer can be focusing on their own strength instead of the background knowledges.
Thank you very much, Dr. Chen. And as he has said earlier, I think one of the points that I'd like to reiterate is that NI comes in to really help ARTC to extract the complexity of developing the system so that the engineers and scientists in ARTC can really focus on the real research stuff. And also, I'd like to also add that in both test bed that ARTC is working on, there are a very complex systems of trying to synchronize data measurements, inspections, real time. And we are very happy to be able to say that NI can actually help ARTC to achieve that. And with the buzz of the Industry 4.0 and the cyber physical of things, and also the factory of the future, we really look forward to working very closely with ARTCs to address some of those new emerging technologies application. So with that, thank you very much, Dr. Chen.
Thank you, Raj.
Thank you. Now, the 4th speaker that I'd like to invite is Saris. But before that, I just wanted to share that in today's world, you will see that there is a growing interest globally to develop renewable energy technology. In order to mitigate climate change, there is a need to reduce the carbon intensity of the global energy system. And this is done by adding clean, renewable energy source such as solar power. And that is exactly what Saris has been doing right here in Singapore all this time. To talk more about the challenges that they face and how they overcome it, let's welcome on stage Mark and So from Saris. Good morning or good afternoon now. Very good to see you, So.
Good afternoon.
Good afternoon, Mark. Thank you. Now, we all know that Saris is sponsored by National University of Singapore and the Singapore National Research Foundation through the Singapore Economic Development Board. But please tell us more about your institute.
Good afternoon. Saris Solar Energy Research Institute of Singapore, it was founded in 2008. And we are also part of National University of Singapore. Our main R&D focus is on PV, ranging from cells, modules, system to solar buildings. And we are also specialized in professional services for PV industry. Our vision is to become leading solar energy research institute in the world, contributing globally sustainable development. Within itself, the main objective of our LabVIEW team is to develop a network of remote stations and infrastructure for live and historical data collection, storage, processing, and sharing.
Thank you very much for sharing. That is perfect. I'm pretty sure that Ceres is becoming the knowledge of hub for solar power, not only just in Singapore, but to the entire Asia itself. So in your own experience, Mark, will you be able to share the challenges in your specific requirements based on your involvement so far?
Yes, sure. In 2010, our LabVIEW team at Ceres was given a task to develop a network of monitoring stations that covers 25 sectors of the entire island of Singapore in the purpose of monitoring meteorological and electrical parameters from PV installations. The critical parameter was solar irradiance, which then translates into energy production from PV installations. So that was the first critical parameter. The second set of parameters were meteorological. All these were used for solar irradiance forecasting. This is important for the power generation authorities to keep the grid stable, right? So they need to know ahead how much power will be generated 20 minutes from now. We also were given a task to monitor electrical parameters to assess the performance and the condition of solar PV systems. Ceres was looking for something beyond just the normal data loggers that are available off the shelf or even services provided by the company. Ceres wanted to have their own system, own the code, control the features. So we were given a long list of features that would need to be implemented. I just list a few because the list is very long. The first major thing was live data. The data loggers, remote stations, were supposed to log data on site, plus send live data every second to Ceres, every minute, upload daily data at the end of each day to Ceres. That's not all. If we receive data for scientific purpose, the data must be correctly time-stamped. It means if we have, like currently, almost 60 stations, all data records must be correctly time-stamped. So we managed to synchronize all our stations, Singapore and overseas, to be within plus minus 150 milliseconds, using our own time server. Everything was programmed in LabVIEW. So these are the main features, plus, of course, the remote stations should be intelligent enough, smart enough to allow us to connect to the station, upload scaling coefficients, enable, disable certain sensors and measuring devices. On the backbone at Ceres, we should have the ability to collect data, process data, share data, generate customized reports. So we are doing this and sharing the data with Ceres research teams as well as with Ceres customers.
Thank you very much, Mark, for sharing. And it is good to know that the challenges and the requirements were identified early, well before any important decision were made. Extremely important for design methodology. I also know that the solution of choice is the NI hardware and the NI software. And you have been using the NI Compact Rail Industrial Controller and the NI C-Series I/O modules together with the NI LabVIEW software, NI LabVIEW real-time software, and NI LabVIEW FPGA software to program for the central monitoring system and to program for the remote monitoring station. And so I'm really very interested to know more about some of those applications that you have been working on using the platform.
Okay, so the first milestone for LabVIEW team at Ceres was to develop a network of 25 stations that transmit live 1-second irradiance data to Ceres. This system was completed in December 2013, and this date also marks the birth of live solar irradiance map for Singapore. We believe this is the first live irradiance map in the world, due to the high density of irradiance sensors in Singapore, as it's a small area. So we managed to get the live irradiance map online, which is updated every second. Currently, we have 53 monitoring stations in Singapore, 3 in India, and 2 in Cambodia. Soon, we will be expanding our systems to countries like China, Japan, Australia, and Indonesia.
For the first PV floating system in Southeast Asia. We will be deploying motion monitoring system of PV platforms using a 6-degree of freedom sensor with compact Rio and NI campus module. We would like to show you a very short video clip of our system, followed by our live irradiance map. This is the UI of our system. The system has a bunch of features. One of the features is able to detect the sinking platform, as you can see in the video. Another feature is able to detect the impact caused by the foreign object.
So monitoring of the behavior of the platform is critical for first in the region floating PV system. This is the equipment that you just saw that we use. These are the photos of the actual site, and the works are being carried as we speak right now. The system should be online very soon. Now we are moving into the series monitoring lab. That's how it looks with the video wall, which shows all the live information, and we'll show you the demo. This is actually user interface of our live system that displays current status of all 58 stations that are running every minute, every second. It shows the download data if any station has a problem. We also collect 1-second data, as you saw for the irradiance map, which allows, this is the irradiance map. As you can see, this is being updated every 2-3 seconds. It's live. The same map is available on the website called National Solar Repository of Singapore. You can view this map that is updated every minute. So data is flowing to Ceres, and we're generating this map. Now we will show you live data from Ceres' own meteorological station located at the roof of our building. You see selected parameters are being shown on the graph, and data is being updated every second. Everything is through NI Compact Rio and our backbone that is collecting the data.
Now, that is really a very impressive demo. But I also wanted to say what is even more impressive is that it came to my understanding that the team consists of just 2 persons. And both of you have basically created a platform using NI to support so many of your projects and so many of your applications. So tell me, how has that worked out for your benefit so far?
It worked very well. From our initial experience, we started actually with industrial PC-based remote stations, right? That was the initial design. But then we found out that LabVIEW, RT, and NI Compact Rio provide much higher reliability. We don't have so many failures, right? Actually, it's a very robust system. This system is much more robust, much more efficient, and easier to program. The great advantage of, forgot to mention, we have 99.5% data availability. This means something, right? How reliable is the system? The great advantage of using National Instruments hardware software as a platform is the wide range of input modules for various types of signals that we connect, as well as the variety of communication protocols, because our system relies heavily on communications. We have this with NI system. It's there. Also, LabVIEW as a graphical programming language provides multitude of tools that speeds up the development. So that's the productivity.
Well, it certainly showed that you have been very successful in all these applications and deployment that you have made. Now, suddenly, a question just popped onto my mind, and I thought I wanted to ask you, Mark, if there is one thing that you will miss the most if you cannot use the NI platform, what will that be?
Productivity, as I mentioned before. If we are forced to move our system that took 6 years to develop now to a totally different platform, it will be a daunting task. It will take a huge amount of manpower and a very long time. So we made the right choice, because within 6 years, actually the system was already online a few years back, but 6 years until now, and it's still being developed. So this would be practically impossible task.
Well, that is really very nice to know, and thank you, Mark. And I still have one more question. What is your future plan for your applications in terms of requirements like systems, complexity, increased market opportunities, system expansions, or more analysis based on additional data that you have acquired?
We plan to expand our data processing backbone, because I didn't mention there's a heavy backbone that supports the large number of stations, right? So we need to expand our abilities in data processing, generating reports, automated, live feedback, live diagnostics, all this. So there is a lot of work. Also, as National Instruments releases more powerful compact trios, new models, we will be adding more and more features, making those data loggers more intelligent, smarter, and more reliable. We are also planning to increase the number of monitoring stations around Singapore on the neighboring islands. Why? To enhance the capabilities of irradiance forecasting for Singapore. This is crucial for power utilities. If we have stations around Singapore, forecasting of irradiance for the next 20 minutes will be much more precise. We are also planning to support existing and new customers that require monitoring, reliable monitoring system using NI hardware and software. And we're also planning to move into new areas in the renewable energy. The new areas are appearing, and there are plenty of applications for this kind of reliable systems.
Now that is perfect. I guess it is safe for me to assume that you will be back on stage here again real soon with new applications and success story to share with the audience.
Absolutely, YH.
Thank you so much, Mark. Thank you, So.
Thank you.
Thank you. Well, you have heard the success stories from 4 of our customers and partners, and I think you probably understand now why when I started the keynote earlier that I am so excited to share with you. Now, in the second part of NIDays today, you will be having a more deep dive into the technologies behind our platform and also the vibrant ecosystems that we have created. I hope that you have a good NIDays. Thank you.
Get the clicker. Thank you. So definitely some amazing examples from right here in Singapore of some amazing customer innovation. I think YH made a great point in that as we move further into the day, you'll have the opportunity to explore the applications and technologies that we've touched on in some detail this morning in a lot more depth in the different technical tracks. And again, big thank you to our customers and partners, SIT, ARTC, Acusis, and Ceres for taking the time to share with us their wonderful innovation. So thank you once again. So for the next short while, it gives me great pleasure to announce some of our winners of our annual regional paper contest, the NI Engineering Impact Awards. So the NI ASEAN Engineering Impact Awards are now in their 12th year, which is fantastic. And it's a paper contest designed to recognize scientists, engineers, and researchers to take advantage of the NI platform to deliver innovative applications that can have a significant and meaningful impact to the industries in which they specialize. Now, there are several different categories: industrial machinery and control, energy, semiconductor and electronics, test, research, as well as RF, wireless, and mobile communications. You can see we have 5 different categories, and then we have an overall paper winner, as well as the Editor's Choice Award, which is being selected by one of our judging panel and our official media partner and supporter of the Engineering Impact Awards, Mr. Mark Johnson from Industrial Automation Asia, who will be joining me on stage in just a little while. So the papers are judged by a panel of judges individually on a variety of different attributes, including, of course, the complexity of the application and the potential impact it has on the industry, hence the Engineering Impact Awards. Now, I will share a bit of an overview on each of the applications before we announce the winners. So we actually have, of the 7 winning categories, we have 2 winners here in Singapore. Now, I should mention that we extended the ASEAN Engineering Impact Awards to Australia and New Zealand for the first time in 2016. So kudos to Singapore. We have 2 winners from the papers submitted from local industry, and I should add that we had a very large number of papers submitted across the categories once again in 2016. So certainly thank you to all of those that took the time to submit, and really we thank you for the impact that you're having in industry with our platform. So Our first winning paper, and I'll move over here to the lectern, is in the category of RF, wireless, and communications. So the paper is titled A Secure and High Data Rate Wireless System Using OEM States of EM Wave. So to give you a bit more detail, the challenge here was to design and secure a high data rate wireless communication system which is resilient in the presence of strong jamming or intercepting signals by encoding information in different orbital angular momentum, OAM states, or electromagnetic EM wave. Now, the authors were successful in doing so by encoding this information using the OAM states of the EM wave, which allowed simultaneous transmission of multiple channels using the same frequency band, allowing them to create a secure communication link which is resilient against jamming and the intercepting of signals. Now, this really looks to address some significant challenges that face us in wireless. We're talking about the forecast saturation in the available spectrum with the expected growth in the number of wireless devices with the rise of the IoT, the vulnerability to disruption and interception, essentially security of the signal, and also reliability, so severe signal degradation due to fading. So really looking to address some significant challenges that can have a real impact in industry. Now, they were able to achieve their desired results with a combination of LabVIEW, PXI hardware, and in particular, the vector signal transceiver, which we had the opportunity to hear from Dr. Ellingson about in this morning's keynote presentation. So that's our first winning paper in the category of RF, wireless, and communications. I will talk a little bit more about our second winning paper before we announce the winner. So the second paper looks at a smart recirculating agriculture system. Now, this is, of course, an application area that has quite significant potential and importance here in Singapore to really meet the growing needs of the local agriculture industry. Here, by using NI compact RIO, NI wireless sensor nodes, a variety of sensors and actuators, they were able to build a scalable recirculating agriculture system that can continuously monitor and control water quality, as well as perform alarming and reporting where conditions are harmful to fish and fish health. So you can see both these applications, in the spirit of the Impact Awards, have potential to have a significant impact within their said industries. So at this point, could I please ask our Marketing Director for Asia Pacific, Mr. Ryota Akita, to join us on the stage? Welcome, Ryota. Very happy to have you here with us for NIDays Singapore. So, to announce the winner of the category for the winner of the paper for RF, wireless, and communications, please join me in welcoming to the stage Associate Professor Tan Sum Yim and Pasan Basitha de Silva from Nanyang Technological University. Congratulations again, Professor Yim and Mr. De Silva. Okay, at this stage, I'd also like to invite Mark Johnson, Editor at Industrial Automation Asia, to join us on the stage here. Now, as our media partner and selector of the Editor's Choice Award, Mark has also taken the time to review all of the papers and not only contribute to the overall marking, but select the winner of the Editor's Choice Award. So thank you, Mark, for being here with us today. Almost lost my clicker there. Okay, so for the winner, for the Editor's Choice Award, please join me in welcoming to the stage from SIT, Professor Yung Ken Lim, from Baizana, Raymond Sia, and from Providev, Sanka Hitirachi. So congratulations once again to all of our winners here today in Singapore. And again, congratulations and thank you to everybody that submitted a paper and for the innovation that you're delivering with the NI platform. At this point, I would just like to take a brief moment to extend our thanks to Mark for the time and effort and support of the Engineering Impact Awards with a small plaque to, as a token of appreciation. So, ladies and gentlemen, please, a round of applause for Mr. Johnson. Okay. Thank you, Mark. Thank you, Riota.